Good morning. It's Wednesday, March 18th, and you're looking at a live view of Falcon 9 as it awaits its 8:16 a.m. Eastern Time launch from Pad 39A at Kennedy Space Center in Florida. Welcome back to SpaceX headquarters in Hawthorne, California. My name is Jesse Anderson, and I'm a lead manufacturing engineer here at SpaceX. You're watching a live webcast for our sixth Starlink mission and our sixth mission overall this year in 2020. If you joined us on Sunday morning, you know that we had a standard auto abort triggered right before liftoff. At SpaceX, we intentionally hold down the rocket prior to liftoff to ensure engines reach correct power levels. On Sunday morning, we had an out-of-family engine reading, which caused an automatic abort. Typically, we would try again the next day, but today was the first available day on the range, so here we are. As a reminder, today we're launching a set of 60 Starlink satellites. Starlink is designed to provide high-speed, low-latency internet all over the globe, particularly in remote or rural areas where connectivity is limited or completely unavailable. Today's mission will also be the first time we are flying a booster for the fifth time. The most recent flight of this booster was our second Starlink mission back in November. Just like our first stages, we are also starting to reuse our fairings. Today we're flying a reused fairing which previously flew on our first Starlink mission. With that, all systems are go for an on-time liftoff this morning.
Hello, my name is Michael Andrews and I'm a supply chain supervisor here at SpaceX. And this is our Falcon 9, vertical once again at Launch Pad 39A down at Florida's Kennedy Space Center. The bottom two-thirds of the vehicle, the part of the vehicle that looks to be covered with soot, is our reflown first stage. This first stage uses its 9 Merlin M1D engines to power the vehicle through the Earth's atmosphere out to the edge of space. And today we'll be attempting to recover that first stage again, actually for the fifth time, on our drone ship, Of Course I Still Love You, which you can currently see. It's stationed about 350 nautical miles northeast of the Cape. Above that first stage is our black interstage band. It connects the second stage at the top, which will carry our 60 Starlink satellites to a deployment altitude of 440 kilometers above the Earth's surface. From there, they will be deployed and use their individual propulsion systems to move up to their operational altitude of 550 kilometers. The Falcon 9 you see on the pad has been loading propellants since T-minus 35 minutes. As a reminder, we use a mixture of rocket-grade kerosene, known as RP1, and super-chilled liquid oxygen, known as LOX, to power the Falcon 9. Currently, our RP1 is nearly fully loaded on the first stage, and it is 100% loaded on the second stage. LOX loading, however, is still underway on both stages, and that will actually continue to be topped off right until the last minute of our countdown. And at the very top is our stack of 60 Starlink satellites. They're safely enclosed inside that 17-foot diameter payload fairing. It's the pointed cone on the very top of the rocket. And like we've attempted in our past couple launches, we'll be attempting again today to recover the fairing pieces again with our 2 recovery ships, Miss Tree and Miss Chief. They're currently positioned in the North Atlantic Ocean off the coast of North Carolina. In terms of weather conditions today, we do have a few scattered cumulus clouds, but nothing gating us from today's launch. Winds, both at ground and altitude, are nominal. The Air Force range is prepared to support today's mission. So with that, our vehicle, our Starlink satellites, the weather and range are all looking green for an on-time liftoff just a few minutes from now.
As I mentioned at the top of the webcast, today's launch will be the first fifth flight of a Falcon 9 booster, and if we land it successfully, it will mark the 51st recovery since we started landing our boosters back in December of 2015. Reusability is core to our mission here at SpaceX, which brings me to our efforts underway in Boca Chica, Texas, where we are building and testing Starship, our next generation spacecraft. If you joined us Sunday for our first attempt of this mission, we shared an update on Starship and the progress that the teams in Boca Chica are making. The local team has executed a variety of tests designed to push the limits of the vehicle, and the site continues to change daily as production ramps up. We have a series of upcoming static fire and short flight tests with our serial number 3 test article, and longer flights with serial number 4, but ramping up our Starship and Raptor production line is what matters most. The design goal for Starship is 3 flights per day on average, which equates to roughly 1,000 flights per year at greater than 100 tons per flight. This means every 10 ships would yield 1 megaton per year to orbit. This is a significant effort, and we are looking for highly skilled engineers and welders to help us make this a reality. If you're interested in joining the team, please take a look at spacex.com/careers.
We're currently T-minus 4.5 minutes from liftoff, and Falcon 9 is now moving into the final stages of its countdown. Back at T-minus 7 minutes, our engine chill process began. This is where we allow a small amount of that super chilled liquid oxygen to flow into the Merlin engine turbo pumps prior to the full flow of liquid oxygen into the vehicle. You have to realize that our RP1 is coming in at about 15 degrees Fahrenheit, but that liquid oxygen is less than negative 300 degrees Fahrenheit. This engine chill helps us avoid any kind of thermal shocks to our system. Liquid oxygen is also what's creating the white clouds you see around Falcon 9. We continue to load that super chilled LOX into the stage just before liftoff, but when that LOX comes into contact with the ambient air around it, it creates those clouds that you see because of boiling. And right below the fairing is our cradle. It's those arms that hold the vehicle in place. They just opened up at around T-minus 4.5 minutes. And right now, the transporter erector, that vertical truss structure, is starting to slowly retract a few degrees. It may be hard to see, but guaranteed this retraction is enough for Falcon 9 to clear the pad. In terms of propellant, the first and second stages, when you add up that kerosene fuel and liquid oxygen, it's 1 million pounds of propellant. That vehicle will finish prop loading at T-minus 2 minutes, with the first stage LOX being at 100% full. And the last call out you'll hear before go launch is at T-minus 1 minute. You'll hear that Falcon 9 is in startup mode. This means that the rocket's autonomous internal flight computers have taken over the launch countdown. Our Starlink payload continues to be healthy. The Falcon 9 team is tracking no issues on the rocket. Weather is still looking good and the range is green for launch, so all that's left to do is listen in to the last few minutes of our countdown.
And stage 2 LOX load is closed out. Vehicles in startup.
LDs go for launch.
T-minus 15 seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Ignition.
It's T plus 40 seconds, and we've just had liftoff of our Falcon 9 vehicle, taking our
Power and telemetry
Starlink
nominal.
payload to its targeted deployment orbit. We are now throttling down and throttling back up in preparation for max Q, which is coming up here in about 10 seconds or so. Max Q is the maximum aerodynamic pressure that the vehicle sees throughout ascent, so this is the largest structural load that the vehicle will see. Should hear that call out in about 5 seconds.
Maximum aerodynamic pressure.
And there's that call out for max Q, confirmation that we've just passed through max Q. Coming up in about a minute, we will have 3 events in rapid succession. The first of which being main engine cutoff, or what we call MECO. This is where all 9 of our M1D engines shut off and slow the vehicle down for the following event, which is stage separation. And that's when the first stage separates from the second stage. And then finally, the lighting of our second stage MVAC engine, which we call SES-1, or Second Engine Start 1. Now, if you've been following our Starlink missions, you know that we've reduced the number of burns on the second stage for these missions from 2 burns down to just 1 single burn. This allows the second stage to provide 70% of the velocity needed for this mission, which allows the first stage to use less fuel and thus making first stage recovery much easier. So today we will again only be doing 1 burn of that second stage engine. Again, coming up in about 10 seconds are those 3 events: MECO, stage separation, and SES-1.
MECO 1.
Stage separation confirmed.
And back ignition.
And there we've just had MECO and stage separation. That stage separation confirms the successful 5th use of our first stage booster. And you can see on your right screen that second stage MVAC engine lighting up and taking that second stage to its targeted orbit. And we're just a few seconds away from fairing deploy. Again, this fairing was used once
Fairing
before on our
separation
very
confirmed.
first Starlink mission. And there is the visual confirmation of fairing deploy. So this means that we've successfully reused this fairing. So now let's see if Miss Tree and Miss Chief can catch those fairing halves today. We likely won't have that live view since fairing touchdown will
Stage
happen
propulsion nominal.
past the conclusion of this morning's webcast, but stay tuned to our social media for updates later this morning.
Stage 2 is on a nominal trajectory.
Acquisition of signal Bermuda.
For those of you just joining us, good morning and welcome. We just had a successful liftoff of our Falcon 9 about 4 minutes ago. There's a lot going on right now. On the right-hand side of your screen, our second stage. Its Merlin vacuum engine is currently burning and will continue to do so for a few minutes. It's carrying 60 Starlink satellites for eventual payload deploy. But we're going to focus the next few minutes on the left-hand side of the screen with our first stage. Currently right now, after stage separation, that first stage is boosting, still gliding up without any engine power. It's hitting apogee just about now, and for the next few seconds, it's going to start to free fall down to the Earth's surface for an attempted first stage recovery on our drone ship in the Atlantic Ocean. As our first stage reorients itself, we're going to prepare for the first of 2 engine burns on that first stage to aid our recovery, the first of which is coming up in about 90 seconds. It's known as our entry burn. We fire 3 of the 9 Merlin engines in the opposite direction the way we're heading. We do this in order to slow down the vehicle about 25% before we hit the dense part of the atmosphere. Not performing this burn would put unnecessary strain on our first stage. We're just at about T plus 6 minutes. We're a little more than 45 seconds away from that engine burn. It only lasts about 10 seconds. And although our first stage only takes a few minutes to get from its apogee down to the Earth's surface, our two fairing halves takes much longer. Please stay posted with our social media for updates on those recoveries. We're about 15 seconds away from that entry burn. We're going to wait for that visual confirmation the burn started and call out that that engine burn was successful.
Stage 1
engine
FTS
burn
is
startup.
safe.
Stage 2 continues to follow a nominal trajectory.
Stage 1, entry burn shut down.
Our entry burn has just completed. The next step is our landing burn. It's about 90 seconds from now. In terms of velocity reduction, with the remaining velocity, the denser part of the atmosphere actually slows our Falcon 9 by 80%, and the landing burn achieves just that last bit of reduction down to 0. And although we're focused on first stage recovery at the moment, at T plus 9 minutes, a little bit less than that, our second stage, its engine will cut off, will then confirm it's in good orbit, and will then begin the preparations for payload deploy.
Starting terminal guidance.
We're about 10 seconds away from that landing burn call out. We'll sit tight and see if we can get any feed of that event.
Stage 2 FTS is saved.
We're still waiting on call out and confirmation for that first stage, but that's our secondary mission. Right now we'll focus on our primary mission with that second stage and our Starlink satellites. We're waiting for that confirmation of second engine cutoff.
We have Zico on.
Our cutoff has completed. We're now waiting for confirmation of good orbit before we begin payload deploy.
Expected loss of signal.
So we've achieved that good orbit for our second stage, but we're not in the right
Newfoundland.
position in that orbit yet. Second stage is now going to coast in this orbit for a few minutes. During this time, you're going to see the second stage is going to start to spin along its central axis. This gives the Starlink satellites the momentum they need to space themselves out over time after they deploy. Think of it as if you were hanging on the edge of a merry-go-round and you jumped off and it slings you out. We use this natural deployment, and it prevents us from having to install complex and heavy separation mechanisms on each and every satellite. So while we wait for that position to be achieved, we're going to take a quick break, and we'll return at T plus 13 minutes, 45 seconds.
Starting deploy spin up.
Expected loss of signal, Bermuda.
Welcome back to the webcast for Starlink. We had an on-time liftoff this morning at 8:16 a.m. Eastern Time. Our first stage successfully separated from the second stage, but unfortunately we did get confirmation that we were not able to land that first stage today. We are obviously disappointed, but our primary mission on second stage is still on target to drop our Starlink satellites to their deployment orbit. One quick update, as many of you know, we've been running a number of tests to reduce the reflectivity of these Starlink satellites on their way to orbit. The first of these tests involve using paint to darken portions of the satellite. Preliminary results show a notable reduction, but we have a couple other ideas that we think could reduce the reflectivity even further. The most promising being a sunshade that would operate in the same way as a patio umbrella or a sun visor, but for the satellite. The sunshade option is slated for a future Starlink launch, and all of these efforts are ongoing and will continue to report results back as we receive them. We're now coming up on deployment of our Starlink satellites, so let's listen in for that call out. We should be able to see separation live, so we'll wait for that live view.
Payload separation confirmed.
So we did get confirmation of deployment, and there is that live view. So you can see on your screen the satellites are slowly separating away from the second stage, and over the next few weeks they will distance themselves from each other and eventually use their onboard ion thrusters to make their way to their final orbit.
And with that successful deployment, that brings our webcast to a close for today. To recap our mission, we had a successful liftoff of Falcon 9 from Kennedy Space Center at 8:16 a.m. Eastern Time. We had a successful separation of that first stage from the second stage. Unfortunately, we did not recover that first stage for another launch, but as you can see, 60 healthy and operational Starlink satellites are on their way to their intended orbits. It's definitely been an exciting launch today. We want to thank the 45th Space Wing for range safety and the FAA for licensing today's launch. And we'd also like to thank you, all of our viewers, for tuning in. Please follow our website and social media platforms for updates on our next missions and milestones. Until the next time, please take care and have a great day.